this C to end migration. અહીંયા સુધી એક્સપ્લેન કર્યું હતું કે આગળ આપણે એક્સપ્લેન કર્યું છે, કોઈને ખ્યાલ છે?
The slide is not visible.
શું થાય છે?
સ્લાઇડ નથી દેખાતી.
Your voice is not also clear.
સ્લાઇડ નથી દેખાઈ રહી. હાલમાં દેખાય છે સ્લાઇડ?
No, sir.
No,
No,
sir.
sir.
No, sir. Voice are not clear, sir.
Voice is also not clear. Okay. Is it connected?
Yes, sir.
Yes, sir.
Yes, sir.
I am sharing the screen. If it is not visible, then update me. Is it visible to you?
No, sir.
No,
No,
sir.
sir.
I don't know why. I'm audible to you, and I'm sharing my screen. So if it is visible, then inform me. If not, then I will try my best to resolve the issue. Now I think is it clear?
No, sir. It's not visible.
No,
Hello.
sir.
But on my screen it is visible. I'm using the same platform which I have used earlier.
Okay, sir. It's visible.
Visible, sir. Now visible.
Now visible. Okay. So I have to keep my
Yes,
phone near to me only because there is some network issue. So okay. With this, I think we have discussed about the C2N migration, and C2N migration we have discussed about the reaction possible by nitrine. Means if you are having nitrogen, then nitrogen is having different types of format. In different types of format, we can say if you are having nitrogen, then nitrogen may be in this form. This form means Rn. This is known as nitrine, or if maybe in this form RNH plus. In both the case, nitrogen having deficiency of electron, this part is known as nitrine and this one is known as nitrogen cation, means nitrogen having positive charge. Both are known as electron deficient. Why both are known as electron deficient? Because here we can see 6 electrons are there, and due to the presence of 6 electron, as per the octet rule, this nitrogen having deficiency of electron. This nitrogen is also having deficiency of electron because as per the octet rule, this nitrogen is also having 6 electrons. So in both the case, nitrogen having six electrons, that's why we can consider as a electron deficient nitrogen. And if electron deficient nitrogens are there, then nucleophile may attack and then after the further reaction is take place. Also, we can discuss the another thing of nitrogen, that is nitrogen is in this form NH3, and then after nitrogen has donated electron to one more hydrogen. So it is converted into NH4 plus. But when it converted into NH4 plus, here the positive charge is just to show that nitrogen has donated its electron to hydrogen, nothing else. Yes, as per the availability of nitrogen, nitrogen having how many electrons? 8 electrons in its surrounding, and that's why it is or consider that it is electron sufficient. But nitrogen has given electron to hydrogen, that's why only we have put positive charge, means whenever the coordinate covalent bond is formed, in that the atom which is donating electron, that atom should have positive charge, and that's why we have mentioned. But we cannot carry out a reaction that is called nucleophilic reaction over here. Okay, why? Because no empty orbital or free orbital or vacant orbital is available with the nitrogen. But here we can carry out the reaction. Why? These are electron deficient and orbitals are available, space is available for the nucleophile, and that's why we can about the special type of reactive intermediates. Based on that, we will complete the reaction, and this type of reaction are known as migration of the group from electron sufficient carbon to the electron deficient nitrogen. Last time I have discussed this part, but here it is important. The reason is nitrogen having two types, or sorry, nitrine having two types. One is singlet nitrine. Now when I am talking about the singlet nitrine, means two electrons are present in the same orbital. When I am talking about the triplet nitrine, means two electrons are present in different orbital. This one is that is called triplet nitrine is more stable as compared to the singlet nitrine. or you can say singlet nitrine is unstable rather than triplet. This part we have already discussed. Now, how the nitrine will form, that also we have discussed in the generation of nitrine. But here it is important. That's why I am discussing with you again. HN3, it's the name of chemical. We can write in this form HN double bond N plus double bond N minus. Now in HN3 we are having another resonating structure. The resonating structure is HN minus, then N plus triple bond N. In this condition, nitrogen having positive charge, so nitrogen will pull electron from the N minus containing nitrogen, and as a result it will convert it into HN, that is called nitrine, and nitrogen gas is eliminated. Another reaction where if you are having Rx, alkyl halide, that Rx by treatment with NaN3, it will convert into Rn3. This Rn3 we can write in this form Rn double bond N plus double bond N minus. Then another form Rn minus N plus triple bond N. So in this case what happened? If this nitrogen is giving electron to N plus, then it will convert into Rn. This is called nitrine formation. So I have explained how the nitrine will form from the different types of reagent. If you are having HN3, from HN3 also the nitrine will form. If you are having Rx and by treatment with NaN3, it will convert into Rn3, and then also nitrine will form. We will discuss the formation or generation of nitrine from acid chloride also. Means if you are having RCOCl, then by treatment with NaN3, we will get RCON3. And from RCON3, it will convert into RC double bond ON, that is called nitrine. And then after we carry out the reaction. So various ways of generation of nitrine. We have already discussed this Cartesian reaction, but to brief you or to explain with you in a detailed form, means suppose if you are having acid by treatment with thionyl chloride, that is called SO2Cl2, it will convert into RCOCl, and by treatment with NaN3, it will convert into RCON3. Then this RCON3 will, we can write in this form, that is called RC double bond O N minus N plus N. And then after, by breaking of this bond, it will convert it into N2. And after that, we can get this compound that is called RCON. Its name is nitrine. And this nitrine by further rearrangement, it will isocyanate, that is called RNCO. Now other reaction that is called Hoffman reaction or Hoffman rearrangement, you are very much familiar. You have studied in semester 6 or 5 at undergraduate. RCONH2 when react with Br2 plus NaOH, it will convert into RCONHBr. And from this, removal of HBr will take place by certain reagents or use of certain reagent. It will convert into RCON, that is called acyl nitrine. Now this acyl nitrine will form, and this acyl nitrine further react with water and it will convert it into carbamic acid, and finally we will get the amine. So how nitrine will form and how nitrine will involve in the rearrangement reaction, that I have explained over here. If you have any doubt or confusion, then you can raise your hand. I will answer it, and then after I will move further. कोई query है? कोई क्वेश्चन क्वेरी हो तो पूछी सके.
Sir?
हाँ.
The first step formation of nitrine છે ના સમજાણું.
first step, that is formation of nitrine. How nitrine? मतलब આ સ્ટેપમાં અહીંયા આગળ
ના સર આમાં નહીં. હા, પાછળની સ્લાઇડમાં ના પછી.
આમાં અહીંયા આગળ
હોફમાન રિએક્શનની ઉપર હતું. હા સર.
અહીંયા છે. So RCON3 we can write in this form RC double bond O N minus N plus triple bond N. Okay. And then after by removal of N2, અહીંયા nitrogen gas remove થાય છે. When removal of N2 take place, at that time nitrogen having deficiency of electron, so nitrogen will pull electron from the neighboring nitrogen. When it pull electron from, it will convert it into positive. Means nitrogen ના પોતાના જે ઇલેક્ટ્રોન હતા લોન પેર ઓફ ઇલેક્ટ્રોન એ રહેશે, એટલે કે નેગેટિવ ચાર્જ આવ્યો એ ઇલેક્ટ્રોન રહેશે, પણ પોતે ઇલેક્ટ્રોન રિમૂવ કરે છે, એટલે કે આ ફોર્મ બનશે. એની પાસે લોન પેર ઓફ ઇલેક્ટ્રોન જે નાઇટ્રોજન પાસે ઓલરેડી હોય છે એ પ્લસ બે ઇલેક્ટ્રોન જે નેગેટિવ ચાર્જ ને હતા લીધે હતા એ રહે છે. તો એ that is called generation of nitrine.
Okay sir, thank you.
So here is it clear to you RCON how it form? Devarsi?
Yes sir.
Other or any other student having any doubt? Okay. If there is no confusion or doubt, then I will move further. Smith rearrangement. In the Smith rearrangement, carboxylic acid and hydroxylic acid react in presence of sulfuric acid to give amines. Means if you are carboxylic acid, that carboxylic acid will react with HN3. Okay, HN3 is a highly unstable compound, so it is not advisable to store it. So whenever it required, we can prepare it by carry out reaction between NaN3 and H2SO4. So in situ reaction will take place between NaN3 and H2SO4. We will get HN3. Now this HN3 will react with carboxylic acid, and by several steps we will get amine. Now how it form, that we are going to discuss in via mechanism. So if you are having acid, then we will get amine, as I said. Now instead of amine acid, if you are having ketone, then we can get substituted amine, that is called RC double bond O R1 HN3. It will convert it into RC double bond O NHR2. That is called substituted amine. If you are having aldehyde, then by treatment with HN3, we will get nitrile. It means with the support of this Smith reaction, we can prepare different types of compound. The limitation of Curtius reaction is it is applicable to acid or acid chloride only. Limitation of Hoffman reaction is it will applicable to acid or amide only. Acid or amide only. But Smith reaction is useful for acid, ketone and aldehyde too. Means various types of products we can synthesize. Now step by step we will discuss the mechanism. First, mechanism for acid. When we are having acid, that is called RC double bond O OH. In the acid, if you are as we know, carboxylic acid is acid, But when we are carrying out the reaction is highly acidic condition, that time carboxylic acid is extracting proton. Normally acid gives proton, but here carboxylic acid getting or abstracting proton. So carboxylic acid work or behaving like a base, and that's why the protonation take place, and as a result we will get OH2 plus. Now when we are having OH2 plus, then oxygen having higher negativity, and at present it having deficiency, so it will pull electron from the carbon, and as a result we will get Rc double bond O plus. This one is known as acyl cation. Is known as acyl cation. Now this acyl cation having deficiency of electron, and that's why it react with HN3. React with HN3, nitrogen which having negative charge will attack on this position, and we will get N having now RC double bond ONH and N plus N. Now from this, removal of N2 will take place. Why removal of N2 will take place? Because nitrogen having positive charge. So nitrogen will pull electron from the neighboring nitrogen, and as a result what happened? This nitrogen is giving electron, so this nitrogen will gain positive charge. Okay, and finally we will get this structure RCONH plus. Here you can see nitrogen having positive charge, that's why it is electron deficient, and due to the electron deficient characteristic, migration of the group will take place from electron sufficient carbon to the electron deficient nitrogen. When migration of the group will take place from electron sufficient carbon to the electron deficient nitrogen, at the same time this carbon is also become electron deficient, and this carbon become electron deficient, so carbon will pull electron from the nitrogen and nitrogen will pull electron from the hydrogen, and as a result double bond will form between carbon and nitrogen, and group will now attach, that is R will attach with the N. So what we will get? R N double bond C double bond O, and this one is known as isocyanate. Now this isocyanate in the reaction, so it react with water. Now from where water comes? For ionization of sulfuric acid we require aqueous media, because in absence of aqueous media ionization does not take place. So sulfuric acid water is there, so that water molecule will act as a nucleophile and will attack on the carbon. When it attack on the carbon, migration of the electron will take place from carbon to nitrogen, and as a result we will get this type of structure that is known as carbamic acid. Here NH C double bond O OH, carbamic acid will form. Now this carbamic acid by further decarboxylation reaction means in the carbamic acid again the breaking of bond between carbon and nitrogen will take place, and nitrogen become negative. So when nitrogen become negative, at the same time proton transfer will take place from oxygen to nitrogen. So we will get RNH2. What happened further? This bond electron will migrate over here and double bond will form between carbon and oxygen, and that's why we are having CO2. So CO2 gas will be eliminated, RNH2 will form. So this is called conversion of acid to amine by Schmidt rearrangement. If you have any question, any query regarding this step, you can raise your hand. I will try my best to answer.
Sir, step 2 and
हाँ,
step 3 फरी repeat कर दो.
कयो?
सर रिपीट करो न।
Step 2 and step 3.
Step 2,
તો
step
step
3.
1 પણ
બીજા કોને? Step 1
એક
પણ.
વાર
બીજા
આખું
કોને
જ
ડાઉટ
repeat
છે?
કરી દો ને.
સર रिपीट कराओ
આખો
न।
જ રિપીટ કરી દો.
હા
हाँ सर।
વેરી ગુડ. થેન્ક યુ. Okay. First of all, we are having carboxylic acid. As we know here, carboxylic acid. Normally, carboxylic acid is known as acid, but here the strong acidic condition is there. That is, we are using sulfuric acid. From sulfuric acid, H plus proton is there. That proton will react with oxygen, and here oxygen is abstracting proton. So carboxylic acid is behaving like a base. એટલે કે જે સબસ્ટન્સ અથવા કમ્પાઉન્ડ પ્રોટોન એબ્સ્ટ્રેક્ટ કરે એને આપણે શું કહીએ છીએ બેઝ. એટલે આપણે પ્રોટોન એબ્સ્ટ્રેક્ટ કર્યો એટલે કે સ્વીકાર્યો એટલે આને બેઝ કહીએ. આપણને શું મળશે OH2+. Now when we are having OH2+, oxygen deficiency electron, so oxygen will pull electron from the carbon. So carbon is giving electron to oxygen, and that's why carbon will gain positive charge. So it is known as generation of acyl ion or cation. બરાબર, કાર્બન ઉપર પોઝિટિવ ચાર્જ આવ્યું છે એટલે એને કાર્બોકેટાયન પણ કહી શકાય, એસાઇલ આયન પણ કહી શકાય, એસાઇલ કેટાયન પણ કહી શકાય કારણ કે કાર્બન પાસે પોઝિટિવ ચાર્જ છે. સો આઈ થિંક અહીંયા સુધી ક્લિયર. Now in the reaction we are having HN3 as a reagent, but as we have discussed the structure, how we can write HN3? We can write HN3 in two forms. Here I am going to use one form of HN3, that is called Hn minus n plus n. Now this n minus will attack on acyl carbon. When it attack on acyl carbon, it will convert it. જો તમે અંદર વાતો કરશો તો મને નહીં ખબર પડે અથવા તમને ના ખબર પડે. જો ડાઉટ હોય તો મને બોલો. છે કોઈને ડાઉટ? હમણાં કોઈ કે માઇક અનમ્યુટ કર્યો હતો, શું હતું?
સેમ સ્લાઇડ હતી એટલે
મૂવ નથી થઈ.
ઓકે સર, હવે થઈ ગઈ.
Everybody is requested that when you are attending online class, definitely I should have my proper network, but at the same time you should also have the same proper network. If there is a connectivity issue from any end, if from my end any issue, then nobody will get my answer, voice or slide or video. But if in only one or two or some selected students are not getting the audio or the slide change, it means the issue from your end. Okay, just for your information only. So now we are having this structure that is called RCONH n plus triple bond N. Now here we can see nitrogen having positive charge. So nitrogen having positive charge, it means it having deficiency of electron. So nitrogen will pull electron from neighboring nitrogen, and as a result this nitrogen become positive. When this nitrogen become positive, then what happens? Then migration will take place, that we will discuss in the next slide. But how the positive charge is formed on this nitrogen, how the positive charge, that is called electron deficient nitrogen, is formed, that I have explained over here. Now in the next slide, here you can see nitrogen having positive charge, and that's why the group will migrate with its electron. That is, R will migrate with electrons, means it will pull electron from the carbon and its own. So it is called nucleophilic migration, and as a result it will bind with the nitrogen. When it attaches with the nitrogen, at the same time here the carbon become deficient. So when carbon become deficient, it will pull electron from the nitrogen, and nitrogen will pull electron from the hydrogen, and ultimately deprotonation will take place, and based on deprotonation we will get the product that is called RNC-double-bond-O, that is called isocyanate. Now isocyanate once formed, then isocyanate will react with water. From where water is obtained, we have already discussed. So it react with water. When react with water, it will convert it into carbamic acid. RNHC double bond OOH. Carbamic acid will form. Now this carbamic acid is unstable compound, and that's why nitrogen will pull electron from the carbon. When nitrogen will pull electron from the carbon, nitrogen become negative. At the same time, carbon is attached with the OH. So it will pull electron from the oxygen hydrogen bond, and here double bond will form, and from here the proton will transfer or shift or react or attach with nitrogen, and as a result we will get RNH2. So we are having RNH2 plus CO2. So this way the Smith rearrangement take place and we will get the product. Now if you have query, then you can ask, or those who had query, I think, is it clear to you or not?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Thank you.
Yes,
Thank you.
sir.
Okay, thank you. Now I am moving for the next step of the same rearrangement. We have discussed the attack of hydrogen on where OH. Now I am going to discuss the attack of hydrogen on C double bond O. પહેલા આપણે ડિસ્કસ એના પર કર્યું કે એટેક ઓફ જે હાઇડ્રોજન છે એ ક્યાં થશે, OH ઉપર થશે. હવે આપણે ડિસ્કસ કરી રહ્યા છે કે attack of hydrogen on carbonyl group. Now why it's possible or how it's possible? Why two types of mechanism steps or mechanism is possible? The reason is carboxylic acid, which is having resonating structure by shifting of electron, means here RC double bond O OOH. Okay, from this it will convert it into C double bond O. This will convert it into O minus, and this proton will transfer on this. So as a result, we are having another structure that is called RC double bond OOH. This is called resonating structure. In the resonating structure only the position or arrangement of the groups is changed. Otherwise remain as it is. The characteristic of the compound remain as it is. Instead of this structure, we can write this form that is called RCO minus CO minus and O minus H plus. But as a result, if you write this structure that is called in resonating structure, this carbon become electron deficient, means this carbon become positive. Okay, and that's why we can say if you write this structure, then what happen? The bond electrons, or what we can call the pi bond electrons, will be migrating on oxygen, and as a result oxygen having negative charge, so H can attach over here. So H plus proton will bind over here. When H will bind over here, previously we have said that resonating structure, but when something is bind, the resonating effect will stop or lost by this compound. When resonating effect is lost by this compound, then we can say we will get carbocation. Here the positive charge on the carbon. So we can say it is a carbocation. Now when we are having carbocation, then HN3, that is called hydroxoic acid, will react with this, and as a result RCOH, OH, NH, N plus triple bond N will form. Now from this, first of all, the removal of water molecule is take place, because the carbon having this type of arrangement, carbon is attached with oxygen, oxygen and nitrogen. It means highly unstable compound, highly unstable due to the characteristic of this type of arrangement. It is also known as hemiacetal type of arrangement, and from this, first of all, dehydration will take place. Dehydration means here removal of OH minus. When OH minus is eliminated, this carbon become positive. So at the same time, immediately the group will migrate from this position, that is called hydrogen gives electron to nitrogen, and nitrogen give electron to carbon. As a result, double bond will form. I am showing in the next slide. As a result, what we get? Removal of OH minus and migration of the electron from the nitrogen hydrogen bond, and as a result we will get double bond over here. Okay, so we are having first structure IRCOH double bond N triple bond N. Now nitrogen having positive charge, so removal of N2 gas will take place, and when nitrogen having positive charge, the removal of N2 gas will take place. It means we will get electron deficient nitrogen. અહીંયા આગળ કેવો નાઇટ્રોજન બનશે? Electron deficient, કારણ કે N2 remove થયો છે. When we are having electron deficient nitrogen, at that time migration of the group will take place from electron sufficient carbon to the electron deficient nitrogen. So R will migrate from electron sufficient carbon to the electron deficient nitrogen. At the same time, what happened? At the same time, these carbon become electron deficient. So carbon become electron deficient, but carbon is attached with the OH. And as a result, breaking of this bond will take place, and as a result, it will convert it into C double bond O. And finally, we will get this structure R N double bond C double bond O. And so that isocyanate will form. And after, the steps are remain same. That is called isocyanate. React with water, it will convert it into carbamic acid, and this carbamic acid by rearrangement, breaking of the bond will take place between carbon and nitrogen, and proton transfer will take place, and as a result finally we will get RNH2 plus CO2. I think you are getting what I am talking about, but still if you have any confusion, then you can unmute yourself and ask me. છે કોઈને query?
Hello, sir.
Yeah.
Sir, how can we decide that hydrogen or a proton will attack on carbonyl or OH group?
Both type of reaction is possible. That's why I have explained both. Here we are trying to understand whatever the mechanism or steps or concept are already proved. But both type of possibilities are there.
Okay, sir.
If you write by first part or second part, whichever way you write, both are the correct pathway. In the mechanism, you have to you can choose any one pathway. Is there any confusion or query? If not, then I am moving further. As we have discussed about the characteristic of this reaction, that this reaction is useful for the ketone also. Now, when I am talking about it is useful for ketone also, it means if you are having ketone, then in ketone, as per the characteristic of the carbonyl group, in the carbonyl group, we can observe the mesomeric effect, and due to the mesomeric effect, this oxygen will pull electron. When this oxygen will pull electron, it becomes negative, and carbon is giving electron. That's why it is positive. So that H plus will bind with this, and as a result, we will get here OH, and as a result, we are having carbocation. Now, once we are having carbocation, then whatever the steps we have discussed earlier, same type of reaction take place first. It means hydroxoic acid will react with carbocation. When hydroxoic carbocation, we will get R1COH NH N plus triple bond N. Now from this, removal of water molecule, or we can say dehydration will take place. When dehydration will take place, it means OH will pull electron from carbon, and carbon will pull electron from nitrogen, and nitrogen will pull electron from hydrogen. and as a result we will get this structure R1 double bond N plus triple bond. And now we are having this structure. In this structure, as we know, the characteristic of nitrogen. Nitrogen having deficiency of electron. So nitrogen will pull electron from its neighboring nitrogen. Which nitrogen? N plus nitrogen will pull electron from the neighboring nitrogen, and in that this condition, what happened? This nitrogen, where my cursor is, this nitrogen become electron deficient, so immediately the migration of the group will take place from electron sufficient carbon to the electron deficient nitrogen. So as a result, we will get R1 C plus and double bond N R. As we know, the water is available in the reaction, so water will react with this, and as a result, first of all we will get R1 C OH2 plus double bond NR, and from this molecule or from this compound, first of all deprotonation will take place, and after that rearrangement of the electron will take place. So by deprotonation we will get R1COH double bond NR, and from this further rearrangement of electron will take place, and as a result proton transfer will take place. Means initially or here proton is attached with the hydrogen. When proton is attached with the hydrogen, this proton will migrate on nitrogen. Okay, when it migrate on nitrogen, then we will get NH. Now how and why it is possible? Carbon is giving electron to the nitrogen, and oxygen is carbon is become electron deficient. So oxygen is pulling electron from the hydrogen, and as a result the conversion or rearrangement of electron take place, and we will get RC double bond O NH. This is called amide formation, but here you can see R is there, so it is known as substituted amine formation take place. So from ketone we have synthesized, or we will get the substituted amide. Last part that I have discussed, that is, if aldehyde is present, then what happen? If you are having aldehyde, then what happen? It is, or it will follow the same pathway. It means here we can observe the mesomeric effect. In the mesomeric effect, carbon will pull donate electron to oxygen, or you can say oxygen will pull electron from the carbon, and then that's why oxygen become negative, and oxygen become negative. That's why oxygen will bind with the proton and it will convert it into OH, and carbon has donated electron. That's why carbon having positive charge. So we can call it a carbocation formation. After that, same way hydroxylic acid will react. When hydroxylic acid will react, we will get RCHOH NH plus N plus triple bond N. From this, as we have discussed, next step is dehydration. So dehydration will take place, and by dehydration we will get first of all C plus, okay, by removal of OH minus, and then after nitrogen is pulling electron from the hydrogen, so double bond will form over here, and as a result RCH double bond N and N plus triple bond N will form. So it is called simple dehydration step. After dehydration, removal of N2 gas will take place. Now here by removal of N2 gas, this nitrogen become electron deficient. But here you can see two different groups are there. One is hydrogen, another is methyl. So which group will migrate, or on basis of which migration the major product will form? So as per the migratory aptitude or migratory aptitude principle, the group which having higher electron donating tendency, that group will migrate. So here I have shown the migration of the both. In the first case, the migration of hydrogen from carbon to nitrogen. In the second case, migration of R from carbon to nitrogen. But as per the migratory aptitude, hydrogen will migrate first or having tendency more, or we can say having tendency to more electron releasing capacity. And that's why the major product will be formed on the basis of this. So what we will get now, if you are having R, C plus double bond N, H. Okay, from here, carbon having deficiency of electron, so carbon will pull electron from the nitrogen. When nitrogen is giving electron, this nitrogen become electron deficient, and that's why nitrogen will pull electron from the hydrogen, and finally we will get R C triple bond N. So this one is known as substituted nitrile, or cyano derivatives we can form. But normally CN is there, then it is known as nitrile compound. So nitrile products we can form from the aldehyde. So I think it is clear to everyone that how nitrile will form. And the last, that is called formyl product, means if R will migrate, then what happen? If R will migrate, then we are having H, C plus double bond N, R, and which react with water and it will convert it into OH2 plus first. Then after deprotonation will take place, and we are having now H, COH double bond N, R. From this, migration of proton or proton transfer will take place, and as a result we are having N formyl derivative, NHC double bond OH. Why it is a formyl? Because the general formula of formaldehyde is HCHO. From HCHO, if one hydrogen is replaced by some group, here hydrogen is replaced by amine, so that's why it is known as N-formyl derivative. So N-formyl derivative will form. Now if you have any query, you can raise your hand. I will try my best to answer your queries. Okay. Nobody is having any query, because I think already I have discussed many things for acid, and for aldehyde and ketone it is just repetition of the steps, but you have to practice it well, because it may create a confusion at during the exam. So try your best. Now with this note, I would like to conclude the session, but before leaving the session, I would like to wish you all the best for your internal exam. In the internal exam, as we have discussed about the syllabus up to the reactive intermediates, the syllabus is there. The PPTs are already said. Some students recently joined. Those students are requested to collect PPTs from your friends and try your best to read whatever we have learned or discussed during the sessions. Okay, all the best. Now I am not going to disturb you till the exam is over, but after completion of exam on 13th, 15th and 16th, I will arrange extra classes for you to complete the syllabus related to rearrangement. So till that, all the best, and perform well in your exam. Thank you. You can leave the meeting now.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
ઓલ ધ બેસ્ટ દરેકને. મહેનત કરો, આવી જશે સ્કોર. 30 માંથી 30 કેમ ના આવે, આપણે એ પ્રયત્ન કરવાના છે. Okay, you can leave the meeting. I am also ending the meeting.